now we're going to use the projection operator to find the closest point of a subspace to a given point. So if we start off with a finite dimensional subspace U, then the closest point of U to a given vector V is given by the projection of V to the subspace U. So this is basically fancy language for the old adage that the shortest path between 2 points is a straight line, and that the nearest point of a plane or other subspace to a point is going to be an orthogonal line, right? So the meaning of saying that it's the closest point means that if we look at this expression right here, which is the distance between V and PUV, this is smaller than the distance between V and any other point of U. So the distance is minimized at the projection. All right, and the proof of this is actually quite straightforward, and it's going to proceed by the usual trick. We work with the squares instead, because somehow squaring things makes everything simpler. So we'll look at the square of this guy and show that this is less than or equal to the square of the right-hand side. So first thing is we just add something which is non-negative. So there's the same thing that we just had, but now I'm also going to add on the norm squared of PUV minus U. And what's U? U is just any other vector in U. The key point being that since this term right here is greater than or equal to 0, the inequality is definitely going to be true. Okay, and now actually the two things inside the magnitude squareds, so this vector here and this vector here, these are actually orthogonal to each other. So this becomes norm squared of V minus projection of V plus projection of V minus U by Pythagoras. And so to see this, V minus the projection of U, projection of V to U is in U perp by our previous results. That was, I guess, 655. And we also have that the projection of U, the projection of V to U lies in U. So if we subtract U, then since it's a subspace, the resulting thing is going to be in U. And so these two vectors are orthogonal to each other. And then, of course, the middle terms cancel. And so we have magnitude V minus U quantity squared. So then if we take roots of both sides, we get the thing we wanted. V minus projection to U of V is less than or equal to V minus U in norm. All right. And now, in order to sort of establish the last point, the closest point is PUV. The closest indicates sort of a uniqueness claim. So notice that the inequality in this step is an equality if and only if PUV minus U is equal to 0. And that's equivalent to saying that PUV is equal to U. So that gives us uniqueness. It's the unique minimum of the expression distance to U is given by the projection.